A UPS battery storage room is typically classified as a Class 1, Division 2 hazardous location. This classification arises due to the presence of hydrogen gas, a flammable gas produced during the charging and discharging of lead-acid batteries. Off-gassing of hydrogen gas is a significant concern in UPS battery storage rooms. Hydrogen gas is lighter than air, which means it can accumulate at the ceiling, creating a potential explosion hazard. To mitigate this risk, several measures are commonly implemented. Firstly, proper ventilation is crucial for removing hydrogen gas from the room. Exhaust fans and air inlets should be installed to maintain negative air pressure and prevent the escape of the gas. Secondly, sealed batteries are designed to minimize off-gassing. However, it is important to note that even sealed batteries still emit some hydrogen gas, so ventilation remains a necessity. Thirdly, regular battery maintenance and appropriate charging practices play a vital role in reducing hydrogen production. Overcharging and improper watering can accelerate the release of gas. In addition to off-gassing, several other safety considerations are important for UPS battery storage rooms. 1. Electrical safety is paramount. Batteries contain high voltages, so proper electrical grounding and bonding are essential to prevent electrical hazards. 2. Fire protection measures are required. This includes the installation of fire extinguishers and fire detection systems. 3. Security is important. Access to the room should be restricted to authorized personnel only to prevent accidental contact or tampering. 4. Spill containment is important. In the event of a battery spill, spill containment trays or pads should be in place to contain any leaks or spills. By adhering to these safety measures, UPS battery storage rooms can be operated safely, minimizing the risk of explosion or other hazards. The classification of a UPS battery room as a Class 1 Division 2 hazardous location means that the area is one where flammable gases, in this case hydrogen, may be present under normal operating conditions or may exist frequently because of repair or maintenance operations or leakage. Class 1 refers to flammable gases or vapors being present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 2 indicates that the hazardous material is handled, processed, or used, but is normally confined within closed containers or closed systems from which it can escape only in the event of accidental rupture or breakdown of such containers or systems, or in the event of abnormal operation of equipment. The primary hazard in a UPS battery room is the off-gassing of hydrogen from the batteries. Lead-acid batteries, during charging, produce hydrogen and oxygen through electrolysis of the water in the electrolyte. This is especially true when batteries are nearing full charge or are being overcharged. Hydrogen is a very light and flammable gas, posing a risk of explosion if it accumulates in sufficient concentration and is exposed to an ignition source. Ventilation systems in UPS battery rooms are designed to dilute and remove any accumulated hydrogen gas, maintaining the concentration well below the lower explosive limit, which is about 4% by volume in air. These systems often incorporate exhaust fans positioned near the ceiling where hydrogen tends to accumulate, and fresh air intakes to ensure adequate air circulation. Sealed or valve-regulated lead-acid batteries are designed to minimize gas emissions by recombining the hydrogen and oxygen produced during charging back into water within the battery. However, even these types of batteries can release some gas, especially under conditions of overcharging or high temperatures, making ventilation still necessary. Regular maintenance practices play a key role in minimizing hydrogen production. Proper charging practices, avoiding overcharging, and ensuring that the batteries are properly watered if they are not sealed can reduce the amount of gas produced. Overcharging leads to increased electrolysis and consequently more hydrogen generation. Electrical safety is a critical aspect of UPS battery room design and operation. Batteries can supply significant amounts of current and voltage, creating potential shock and arc flash hazards. Grounding and bonding of all metallic components helps to minimize the risk of electrical shock by providing a low impedance path for fault currents. Proper insulation and guarding of live parts are also essential to prevent accidental contact. Fire protection is another important consideration. Hydrogen is a flammable gas, and battery rooms should be equipped with fire detection and suppression systems suitable for electrical fires. Fire extinguishers of the appropriate type should be readily available, and fire detection systems can provide early warning of a fire, allowing for a rapid response. Security measures are necessary to prevent unauthorized access to the battery room. This helps to prevent accidental damage to the batteries or electrical equipment, as well as tampering that could compromise the safety of the installation. Spill containment is essential to manage potential spills of battery electrolyte, which is typically sulfuric acid. Spill containment trays or pads can contain any leaks or spills, preventing them from spreading and causing damage or injury. Neutralizing agents should also be readily available to neutralize any acid spills. Furthermore, signage is very important. Warning signs should be posted to alert personnel to the hazards present in the room, such as the risk of explosion, electrical shock, and acid spills. These signs should clearly identify the required safety precautions. Regular inspections and maintenance are essential to ensure the ongoing safety of the UPS battery room. Inspections should include checking the ventilation system, electrical connections, fire protection equipment, and spill containment measures. Maintenance should include cleaning, tightening connections, and replacing any worn or damaged components. Adhering to relevant codes and standards is crucial. The design and operation of UPS battery rooms must comply with applicable electrical codes, fire codes, and other relevant standards. These codes provide detailed requirements for ventilation, electrical safety, fire protection, and other safety measures. Proper training for personnel who work in or around UPS battery rooms is essential. Training should cover the hazards associated with batteries, proper safety procedures, and the use of safety equipment. A safety program should be implemented. A comprehensive safety program should be established and followed to ensure the ongoing safety of the UPS battery room. This program should include regular safety audits, hazard assessments, and employee training. In summary, managing the risks associated with UPS battery rooms requires a multifaceted approach that encompasses proper ventilation, sealed batteries, regular maintenance, electrical safety measures, fire protection, security, spill containment, and adherence to relevant codes and standards. By implementing these measures, it is possible to minimize the risk of explosion, electrical shock, acid spills, and other hazards, creating a safe working environment. It is also important to understand the specific requirements of the installation and to consult with qualified professionals to ensure that all safety measures are properly implemented and maintained. Furthermore, it is important to consider the specific type of batteries being used. While lead-acid batteries are the most common type, other types of batteries, such as lithium-ion batteries, are also used in UPS systems. Each type of battery has its own unique safety characteristics and requires specific safety measures. Lithium-ion batteries, for example, can pose a risk of thermal runaway, which can lead to fire or explosion. Therefore, it is important to select the appropriate type of battery for the application and to implement the necessary safety measures. In addition to the technical aspects of safety, it is also important to consider the human factors. Human error is a significant contributor to accidents in industrial settings, and UPS battery rooms are no exception. Therefore, it is important to design the battery room and its associated systems in a way that minimizes the potential for human error. This can include things like clear labeling, ergonomic design, and easy-to-use controls. It is also important to provide adequate training and supervision to personnel who work in the battery room. By addressing both the technical and human factors, it is possible to create a safer and more reliable UPS battery room. Always consult with qualified professionals such as electrical engineers and safety specialists to ensure that the design and operation of the UPS battery room meet all applicable codes and standards. They can also provide valuable guidance on best practices for safety and risk management. It's also very important to consult the battery manufacturer's specifications and recommendations for installation, operation, and maintenance. This will ensure that the batteries are used in a safe and effective manner. Finally, it is important to remember that safety is an ongoing process. The conditions in the battery room can change over time, and new hazards may emerge. Therefore, it is important to regularly review and update the safety program to ensure that it remains effective. This can include things like periodic safety audits, hazard assessments, and employee training. By continuously improving the safety program, it is possible to create a culture of safety in the workplace and to minimize the risk of accidents. The specific requirements for UPS battery room ventilation are often dictated by local and national codes and standards, as well as by the battery manufacturer's recommendations. However, some general principles apply. The ventilation system should be designed to provide adequate air changes per hour to dilute and remove any accumulated hydrogen gas. The number of air changes required will depend on the size of the battery room, the number and type of batteries, and the charging regime. The ventilation system should also be designed to ensure that the concentration of hydrogen gas remains well below the lower explosive limit. This is typically achieved by monitoring the hydrogen concentration and automatically adjusting the ventilation rate as needed. The ventilation system should be designed to prevent the accumulation of hydrogen gas in any areas of the room. This can be achieved by positioning the exhaust fans near the ceiling where hydrogen tends to accumulate, and by ensuring that there are no dead spots where air circulation is poor. The ventilation system should be designed to operate reliably and continuously. This typically involves using high-quality components and providing for redundancy in case of failure. The ventilation system should also be regularly inspected and maintained to ensure that it is operating properly. In addition to these general principles, there are also some specific requirements that may apply depending on the location and the type of batteries being used. For example, some codes may require the use of explosion-proof fans and other equipment in areas where hydrogen gas may be present. Other codes may require the use of specific types of ventilation systems, such as dilution ventilation or local exhaust ventilation. It is important to consult with qualified professionals to ensure that the ventilation system meets all applicable requirements. The National Electrical Code, or NEC, provides guidelines for battery installations, including ventilation requirements. Article 480 covers storage batteries and includes requirements for ventilation in areas where batteries are installed. While the NEC doesn't mandate specific ventilation rates, it emphasizes the need for adequate ventilation to prevent the accumulation of explosive concentrations of flammable gases. This is particularly important for vented lead-acid batteries, which release hydrogen gas during charging. The NEC also addresses other safety aspects of battery installations, such as overcurrent protection, disconnecting means, and wiring methods. It requires that batteries be protected against short circuits and overloads, and that disconnecting means be provided to isolate the batteries from the electrical system. The NEC also specifies the types of wiring methods that are permitted for battery installations, and requires that the wiring be properly sized and installed. In addition to the NEC, other codes and standards may also apply to UPS battery room installations. These may include local building codes, fire codes, and environmental regulations. It is important to consult with local authorities to determine which codes and standards are applicable. The Institute of Electrical and Electronics Engineers, or IEE, also publishes standards related to battery installations. These standards provide guidance on the design, installation, and maintenance of battery systems, and cover topics such as ventilation, grounding, and safety. IEE Standard 485, Recommended Practice for Sizing Lead-Acid Batteries for Stationary Applications, provides guidance on sizing batteries for UPS systems and other stationary applications. IEE Standard 1187, Recommended Practice for Installation Design and Installation of Valve-Regulated Lead-Acid Batteries for Stationary Applications, provides guidance on the installation of valve-regulated lead-acid batteries, including ventilation requirements. These IEE standards are not mandatory, but they are widely recognized as best practices for battery installations. The maintenance of UPS battery systems is critical to ensure their reliability and longevity. Regular maintenance tasks include inspecting the batteries for signs of damage or corrosion, cleaning the battery terminals, and testing the battery voltage and capacity. It is also important to monitor the battery temperature and to ensure that the ventilation system is operating properly. Battery maintenance should be performed by qualified personnel who are familiar with the hazards associated with batteries. Maintenance personnel should wear appropriate personal protective equipment such as gloves, safety glasses, and a face shield. They should also follow all safety procedures to prevent electrical shock and acid burns. A written maintenance plan should be developed and followed to ensure that all maintenance tasks are performed on a regular basis. The maintenance plan should include a schedule of maintenance tasks, a list of required tools and materials, and a description of the procedures to be followed. The maintenance plan should be reviewed and updated periodically to ensure that it remains effective. Proper disposal of used batteries is also important to protect the environment. Used batteries should be recycled or disposed of in accordance with applicable regulations. Lead-acid batteries contain hazardous materials such as lead and sulfuric acid, which can contaminate the environment if they are not properly disposed of. Battery manufacturers and retailers often offer battery recycling programs. These programs provide a convenient way to recycle used batteries and to ensure that they are disposed of safely. It's very important to conduct a hazard assessment of the UPS battery room to identify potential hazards and to develop control measures to mitigate those hazards. The hazard assessment should consider all aspects of the battery room, including the batteries, the electrical equipment, the ventilation system, and the personnel who work in the room. The hazard assessment should identify potential hazards such as electrical shock, acid burns, fire, explosion, and exposure to hazardous materials. The hazard assessment should also evaluate the likelihood and severity of each hazard. Based on the hazard assessment, control measures should be developed to mitigate the identified hazards. Control measures may include engineering controls, administrative controls, and personal protective equipment. Engineering controls are physical changes to the battery room or its equipment that reduce the likelihood or severity of a hazard. Administrative controls are procedures or policies that reduce the likelihood or severity of a hazard. Personal protective equipment is equipment worn by personnel to protect them from hazards. The control measures should be implemented and maintained to ensure that they are effective. The hazard assessment should be reviewed and updated periodically to ensure that it remains accurate and relevant.